Looking at 409 today. So we're looking at radians, or introducing you to the concept of radians. Now, up until this point, you guys have always been working in degrees. So obviously, you know, we know a fair bit about degrees. We know that 360 degrees is a circle. We know that a triangle is made up of 180 degrees, a few different properties. So just like degrees, radians also have their own property. And the easiest way, or something that's going to really help you when working with radians, if I have a circle, would equal 360 degrees, right? So if I had a point in the center, would have 360 degrees all the way around. So with radians we're talking about pi radians, or an amount in terms of pi. So 360 degrees is the same as 2 pi radians, or 2 pi. So effectively, if 2 pi equals 360, that must mean that half a circle, or 180 degrees, equals pi. So 2 pi gives us your revolution, or as you can see here, 1 pi radian is the same as 180. So naturally, if we had a value such as, let's say, 2 pi radians, or 2 pi radians, 2 pi radians is the same as 360. So I could evaluate something like a half a pi radian would be equal to half of, well, 1 pi radian, as we see here, equals 180. So half a pi radian would equal 90 degrees. And we'll have a look at that a bit more further on. So key thing to remember is this fact. This fact will help you in some harder questions, that a circle is the same as 2 pi, and 1 pi radian is the same as 180. Let me just get rid of this here. So looking down the bottom here a little bit. You're moving for me. Okay, so when we can, or we will need to convert between radians and degrees. So there's two different formula there. Why is this not working? One is for converting from degrees to radians, and the other is converting from radians to degrees. And they're both derived from that top formula there, or the top fact that a pi radian equals 180. So we're looking to change from radians to degrees. If I have, let me get rid of this as well, I need to just simply rearrange this formula so that I just have radians on one side. So I need to get rid of the pi here. So obviously at the moment it's multiplying, so I'm dividing both sides. So basically radians equals 180 degrees, or 180 on pi. And as you can see, that's where we get converting from radians to degrees from. We need to multiply by 180 on pi. And when I'm converting from degrees to radians, let's get rid of this, degrees to radians, I'm doing multiplying by pi on 180. Or basically, I'm taking my 180 across, bringing my radians over. Yep. So that's essentially how I do it. And let's have a look at a couple of examples below. So long as you remember pi radians equals 180, you can work out these two down here. Or another good way to look at it is if you want to convert to degrees, you're going to multiply by the fraction where degrees is on the top. If you want to convert to radians, you're going to multiply by the fraction where the radians, or pi, is on the top. So that's another quick way to remember which one you need to multiply by. So let's apply that down here. So moving on to the second page. All right, so over on the left here, I've got our two rules. And we're going to use those to answer these questions from the textbook. Now, I chose the textbook questions because they give a good variety. I didn't want to go picking out small little bits from each question. It was just slightly annoying. So let's have a look at these questions here. All right, question A. Convert 3 pi on 2 into degrees. Okay, so 3 pi on 2 is a radian measurement. It's something in relation to pi. So that's key to remember. So at this current moment, we're multiplying through, we want to convert to degrees. So as we said before, we're looking for the formula where the degree value, or 180, is on top. So I'm multiplying this fraction by 180 on pi. I cross multiply with my fraction, so 180 times 3 gives me 540. So I got 540 pi on top. Yep, over 2 times, and it's losing battery, 2 times pi on the bottom. So as you can see, my pi's would cancel. 540 divided 2 gives me 270. So I can safely set, or I've calculated that 3 pi on 2 is the same as 270 degrees. Okay, another way I could have done that, a quicker way I could have done that question is I know that pi, or 1 pi radian, equals 180. So I could just substitute 180 into where pi is. So that'll look like this. So 3, 180 on 2. Again, you get 540 on 2, which gives us our answer. So let's get rid of this. We'll just put our answer here. Yep, equals 270 degrees. Okay, next question. We're changing from degrees to radians, leaving our answer in terms of pi. So that brings up another good discussion point we'll discuss in a second. Let's have a look at that one. So B, 60 degrees. And what I'm saying to myself, I'm trying to convert to radians. So remember, radians is pi, or pi radians. So I'm looking for multiplying it by where the value where radians is on, or the fraction where radians is on the top. So times pi on 180, 60 times pi on top. And what you want to do here is you want to simplify the fraction, and you're going to get something in terms of pi. So divide both the top and the bottom by 60 to simplify. So 60 goes in itself once, so we just have 1 pi, or pi, on top. 60 into 180 is 3. So that will be our answer there. So 60 degrees is the same as pi on 3. And we can check that because we know that 1 pi radian is 180. Yeah, and 180 on 3 would give us our 60 degrees. So we were to convert it the other way. That proves that we're right, or we're correct. Okay, good. So let's have a look at question C. Again, converting to radians. This time, it wants it to 2 decimal places. So we're not going to just leave it in this form, which is answer in terms of pi. We're actually going to evaluate it as a decimal. So 50 degrees, same thing. We're going to get 50. We're going to multiply it by our fraction where our radians is on top, because we're converting to radians, equals 50 pi on 180. Can we simplify that? I mean, we can, but all right, let's do that. Same as 10 pi on, what is it, 36. Yep. And clearly that's a pretty ugly, I could simplify it even further, but I'm just going to plug that in my calculator. I should have probably done that originally. This is just a bit of pointless working to get a decimal answer, and my answer is going to be 0.87. And this is a key here. Sometimes you'll be asked to leave your radian measurement in terms of pi. Sometimes it's actually easier when working in calculations, but it also always holds a decimal value as well. So depending on what you're working with, you'll need to either do it in terms of pi or you'll need to have its decimal value. We can check that 0.87 is correct by converting it back to degrees. Remember, 1 pi radian equals 180. So if I have 0.87 pi radians, same as 0.87 pi radians, where radians equals 180 degrees. 0.87 times 180 should give me my 50. And that is how we could check to make sure we're correct. So we'll leave that for now. Moving on to D. Let's do a different color. We'll do D up here. So D is change 1.145 radians into degrees to the nearest minute. So again, 1.145 radians into degrees. Multiplying through by 180 on pi. So multiplying by, we want radians to degrees, so I'm going to use the degrees on top. So multiply by 180 on pi. So that should give me 1.145 times 180. It's my numerator, pi is my denominator. Plug that into my calculator to get my answer, and it wants it to the nearest minute. So make sure you press your degrees, minutes, seconds button to swap it from decimal. Should get 65 degrees and 36 minutes. Cool. Okay. Now, converting 38 minutes, 38 degrees, 41 minutes will be exactly the same as converting a whole degree amount. So I'm going into radians. So I say to myself, I want the radian, or multiply through by the radian measurement on top. So I'm getting 38 degrees, 41 minutes times radian on top. So pi on 180. So that gives me my 38 degrees, 41 minutes times pi, all on 180. And when I put in my calculator, I'm going to put it in just as if I was doing an angle. So 38, press the degrees button, 41 degrees button, multiply by pi, divide 180. Hang on, let me just check I'm in the right mode. Yeah, so into radians. Sorry, I'm converting to radian. I'm not converting to degrees. Converting to radians. 0.6, 3 decimal places, 675. Cool. Question F. Kind of run out of room here. I'll do F up the top. Okay, evaluate cos of 1.145 correct to 2 decimal places. Okay, now you're going to see radians pop up. This value here, 1.145, we're used to seeing cos of an angle. So let's say cos of 60 degrees, etc. And when we begin working with radians, basically the same as working with degrees, just in a different format. So two things pop out that tell me that that's a radians measurement. One is that it's in a decimal value. It doesn't have degrees of minutes. And the other is that it just doesn't have a degree sign. So that tells me it's radians. Now, it's important, and on your calculator, you will need, when you're entering this value, to be in radians mode. So to get your calculator into radians mode, and it's going to be quite tricky because we're going to have to be swapping between degrees and radians mode depending on what we're working with. Some people, or I've heard of people before taking in one calculator to the HSC that's in degrees mode and the other in radians, so that they're not going to, slip up and make an error. But basically, we need to just remember whenever we're dealing with or sine, cos, and tan, if we're dealing in degrees, we need to make sure we're in degrees mode, and if it's a radians measurement, we need to make sure we're in radians mode. Otherwise, we're going to get the wrong answer. So to swap modes on the Casio calculator, just the normal, the FX 100AU, you need to press Shift at the top left. That's a terrible shift. And then you need to press the mode button, or in yellow, it should say setup. So I'll just put the mode button here, but the shift button's yellow, meaning choose the yellow option, and then setup is with the mode. And then you should have degrees is number 3. So if you pressed 3, you'll get degrees. It looks like this, 3 deg. And number 4 is radians mode. So if you press 4 RAD, that'll put your calculator in radians mode. So in this instance, to work out this question, we need it in radians. So I'm going to press number 4. And up the top, you'll see it changed to an R instead of a D. So there's D, R, and G modes. And we want it in the radians mode or the R mode. So now I can just put in cos, and in my brackets, put in my 1.145. And that's going to give me my value. And I want it correct to, or my radians value, to correct to 2 decimal places. So once I put that in, F, I get 0.41. Perfect. Now, just remember and this is where it's key, that when you're doing a question, you sort of ask yourself, does this answer make sense? Because if, what I was doing the other day and I had it in the wrong mode is I was getting a negative answer. Well, clearly you can't have a negative angle, so therefore you're probably in the wrong mode. Sometimes it's not that obvious. Sometimes, you'll get a degree, but it just won't make sense in your triangle. So you might get it, might be expecting 60 something degrees, but you only get 1 degree. Well, that's another thing that's going to tell you, hey, I'm probably in the wrong mode, and it needs to be swapped to the right mode. Again, we'll look at that later in class and in future lessons to make sure you guys are, or when to swap modes. But for now, because generally we work in degrees mode, I'm just going to press Shift mode and put it back in degrees, just so I don't slip up and I cover myself for the moment. Yeah, always ask yourself, that's why it's key to ask yourself, does this question and answer make sense? If it doesn't, then check you're in the right mode, pretty much. Okay, another thing you need to know in this exercise is your exact ratios. Okay, so these are exact triangles. You may have seen them before. So I'll go over where we get them. So as you can see, let's focus on this triangle first. Okay, this is a right angled triangle with side lengths or shorter side lengths of 1. So all I've done here is 45 degrees. I've worked out a squared plus b squared equals c squared. So here c would equal, so 1 squared plus, b, which is 1 as well, remembering that this is C, that's A, and that's B. So 1 squared plus 1 squared equals C squared. 1 squared is 1, plus 1 is 2. So 2 equals C squared. So C must equal root 2. And we use this triangle to help us find our exact ratios. So exact ratios happen, as you can see, when we have 30 degrees, 45 degrees in each of our ratios, and 60 degrees. So to do the 45 degrees, we use a right-angled triangle, as we just showed. So we're looking at the middle column at the moment, and this triangle helps us to derive our exact ratios. And these triangles are on your HSC reference sheet, so you don't need to remember the triangles, but it won't actually tell you, it won't give you these. You'll just need to be able to calculate them given the triangle. So sine 45, so as you can see here, let's look at the first one. Sine 45 equals 1 on root 2. And that's because, if I chose, let's say, this angle, remember that sine is opposite, opposite over hypotenuse. So you're going to have your opposite side, which is 1 divided by root 2. So that's our exact ratio of sine 45. That's what it equals, 1 on root 2. Moving on to cos. So cos 45 is 1 on root 2, and that's because if I selected cos of this angle, cos of 45 degrees, see AH, so A is 1 over root 2, that's where I get that ratio from. And lastly, the tan ratio equals 1, and that's because, tan 45 is 1. That's because if we chose this angle, we did tan TOA, opposite over adjacent, is 1 divided 1, which gives us our tan 45 equals 1. The other two, so that's the middle, the 45 degree angle. This other triangle over here, this comes from an equilateral triangle. So the triangle we use, and the reason why we use it with the side length of 2, so equilateral triangle, side length of 2, would mean that these would all be 60 degrees, the angles. So what they've done here is I've just simply cut this triangle in half, straight down the middle. So the distance along the bottom of that triangle was 2, which would mean the new triangle is now 1. And the angle that was at the top was 60 degrees, but we've halved it because we've cut it in half. So now we've got 30 degrees, and that's our right angle there. So that's where they've got this triangle from. And then again, they used Pythagoras. So A squared plus B squared equals C squared. So our sides here, we've got this is C, and that's B. So we're trying to work out B. So plugging my values in, or I know that C, which is 2, so 2 squared, take A squared, which is 1 squared, equals B squared. So 2 squared is 4, take 1 squared is 1, equals B squared, 3 equals B squared, or B equals root 3. And as you can see, that's where they've got this root 3 value from here. So using that triangle, we can now calculate the exact ratios for sine, cos, and tan for either our 30 degree angle or our 60 degree angle. And I'm not going to go, let's just go maybe one of each. So let's have a look at tan 60 degrees. So looking at this one here, so sine 60 degrees. So sine 60 degrees, taking the sine of this angle, sine is O over H, so root 3 opposite over 2, and that's where they get the root 3 on 2 there. And you can go through for cos and tan of that angle and do the same thing. That's where you get the exact ratios. And the same thing for sine or cos and tan of 30 degrees is 1 on 2, because if I took sine of this angle, O over H is 1 on 2 or a half. So that gives me my exact ratio when sine is 30 degrees. Okay. Now, the exact ratios in radians are easy to remember because, as you note, or as you can see, these three are exactly the same as these three. And the only difference being the fact that they have just converted the degrees amount. They've just converted the degrees amount to a radians amount. So as you remember, when we're converting from degrees to radians, 30 degrees, so we would have 30. I want to multiply that by one where radians is on top. So that equals 30 pi on 180. 30 goes into 180 6 times, so same as pi on 6. And as you can see, they've taken pi on 6 and I've just substituted it into here. We can't actually see that now. Yeah, so that's where they get our pi on 6 value from. And then we'll just say to ourselves, we'll come up to the triangle again. We'll know that pi on 6 is the same as 30 degrees. And we could use our 30 degrees, do our O over H to get our half. Cool. So you might get questions that would say evaluate this, or what is the exact ratio of this. But yeah, if you're asked to find exact values, it's good to remember where those two how those two triangles are derived. They are in your reference sheet though. So you using those triangles, you'll just be expected to then be able to derive your exact ratios. So you just look at the the triangle, and say if sine was at this amount, then O over H, and that's how you get your exact fraction or your exact number. So having a look at this, find the exact value of tan pi on 3. So first thing I want to do is I want to take my radians measurement, my pi on 3, and convert it to degrees. Now I could know that pi on 3, because pi radians is 180 on 3, is the same as 60 degrees. Or what we were doing before, multiplying through by, we want to convert it to degrees. So I'm going to choose that fraction where the degrees is on top. Will give me 180 pi on 3 pi. And obviously here, my pi's cancel out. 180 on 3 gives me my 60 degrees. So this question here is like saying the exact value of tan 60 degrees. So if I'm asked to find the exact value of tan 60 degrees, that's where my triangles come into use. So let's first clean them up a bit. Okay, so I look at the triangle, I say the exact value of tan 60 degrees. My 60 degrees is here. I know that tan is opposite over adjacent, so root 3 on 1, or the same as root 3. So tan 60 equals root 3 on 1, or root 3. Perfect. Second question, find the exact value of cos pi on 4. I could either multiply through by 180 on pi, or I'm going to just now, I understand I'm going to do the simpler way. So 180, because pi radians is 180 on 4, gives me 45 degrees. So again, now that I want cos 45, I'm going to look up to my triangles. I'm going to say, okay, well, what is cos 45 exactly equal to? Well, take any 45. Cos is A over H. So I've got 1 on root 2. And that would be my answer. I can't simplify that. Well, not nicely. So yeah, so exact ratio cos 45 is 1 on 2. It's pretty much as easy as that. So that covers the types of questions you'll see in this exercise. So key points to reflect on was, firstly, remember that 2 pi is the equivalent of 360 degrees or a circle. Remember that 1 or pi radian is 180. You can convert between radians and degrees by applying your multiplying through by 2 fractions. Ensure you're in the right mode, whether you're working with degrees or radians. And then also remember that you have your triangles here on your reference sheet. And potentially remember where those triangles come from in case you don't have them supplied. But yeah, you should, at least in the HSC, you will have that supplied for you. Okay, so that covers all the content for this lesson. So good luck, and here to answer any questions should you need.